cell, always dividing, growing, repairing, and reproducing. Welcome to Anthropic Microscopic, a documentary by us, the CCB. Today we'll be documenting the process of the cell cycle and the processes in it. First, I need to explain what we'll see in the microscopic wilderness. Cells are the basis of all life, making up all living beings. Cytoplasm is a gel-like substance inside a cell. The cytoplasm keeps all the organelles in their proper place. Nuclear envelope, or the nuclear membrane, is a nuclear shell that contains the nucleus and the chromatin, which holds them until mitosis occurs. The centriole acts as almost a fishing pole, pulling the chromosomes to each side of the cell during mitosis. The nucleus is a housing area for the nucleolus and the chromatin. The chromatin is a matted up form of the chromosome seen during mitosis. Organelles are the organs of the cell, carrying out necessary functions of the cell for the cell cycle. DNA, or deoxyribonucleic acid, is the instructions on how to build an organism. Although for different types of cells, the DNA is the same throughout, although with different parameters for how to make the cell. Well, let's begin the cycle, starting at the beginning of interphase, or the normal state of the cell. Here the cell does its job, whether it be muscle cells for movement or skin cells blocking infections and foreign substances. Every cell must do its job. During the G1 phase, or gap 1, the cell does whatever job it has been assigned for this period. Afterward, the cell moves into the S phase, or synthesis. During this phase, DNA replication and organelle replication occur for mitosis later on. Next, the cell enters the G2 phase, or the gap 2, where the cell grows to accommodate the mitosis occurring later on. Finally, the most important job of a cell is to divide, grow, repair, reproduce. The final phase, mitosis. The steps of mitosis occur in a very specific order to allow for mitosis to occur successfully. First, in prophase, here the chromatin condenses in the chromosomes and the nucleus begins to disappear. The nuclear envelope disintegrates and the centrioles move to opposite ends of the cell. Second, metaphase. During this process, the chromosomes move to the middle of the cell and form a single file line down the middle as the spindle fibers reach to grab the centromeres at the middle of each chromosome. Third, anaphase occurs. During this phase, the cell begins to stretch outwards and the chromosomes are pulled apart, making sister chromatids as they're pulled toward the centriole. Fourth, telophase is the final phase of mitosis. The chromosomes are pulled completely to each side of the cell, and the cell is beginning to slice itself in half, putting the cytoplasm in each distinct cell. The final phase of mitosis is cytokinesis, where the cell cleaves itself in two and becomes two genetically identical daughter cells. After mitosis, the two new cells both move into the G1 phase as the cell cycle begins again.